Hello students, in this class I should discuss one of the most important reaction of carbonyl compound. What are carbonyl compound? Carbonyl compound are those compounds when the C double bond O group attached with an alkyl group or hydrogen. It can be an alkyl group R or hydrogen. It shouldn't contain any functional group like that. Not carbonyl compound. But this is and these are, both of them are carbonyl compound. C double bond O group attached with an hydrogen and alkyl group can be called as an carbonyl compound. C double bond O group attached with an alkyl group or hydrogen to be called as carbonyl compound. When C double bond O attached with an hydrogen is called aldehyde and it's known as ketone. This reaction is common both aldehyde and ketone, but there is a precondition. Precondition is that the alpha carbon is the carbon next to carbonyl group. Alpha carbon must contain at least one hydrogen. This is the precondition for Aldol condensation reaction. Alpha carbon is the carbon next to carbonyl group. The carbon attached with at least one hydrogen. If the carbon doesn't contain any alpha hydrogen, it shouldn't undergo Aldol condensation reaction. Look at this. H, C double bond O, H, or look at this. Both of them are carbonyl compound, but C double bond O attached with hydrogen. In this case, C double bond O attached with a carbon, but the carbon 4 valencies has been satisfied. There is no hydrogen, so none of them possess no alpha hydrogen. So none of the above should undergo Aldol condensation. But look at it. It's called aldehyde. Or look at this. This is known as ketone. This is the alpha carbon. This is the alpha carbon. This is the alpha carbon. This alpha carbon contains 3 hydrogen. In this case, alpha carbon contains 3 hydrogen. So the precondition is that 2 or more carbonyl molecule same or different when treated with dilute acid or alkali form beta hydroxy carbonyl compound. The two carbonyl compounds undergo addition reaction in presence of a base or dilute acid to form beta hydroxy carbonyl compound, which on heating readily loses a molecule of water. To form alpha beta unsaturated carbonyl compound. So without wasting time, let us tell you the mechanism of the reaction. Okay, suppose look at this compound. Take another one. Here I take two molecules same. It was treated with dilute alkali, OH minus. As carbonyl group is electron attracting group, so the alpha carbon is acidic enough, ionizes, one of the alpha hydrogen ionizes to form carbon ion. As the carbon ion is formed, because this hydrogen is acidic enough, in place of alkali, it loses an hydrogen to form carbon ion. Now think of the case of another molecule. The carbon ion attack the carbon of the carbonyl group, because in this case between C double bond O, oxygen is more electronegative than carbon, should carry positive charge, so it break up, the pi bond break up, carbon carrying positive, oxygen carrying negative charge. The positively charged carbon attack the carbon ion to forming this. It is alpha carbon, it is beta. It's beta hydroxy carbonyl compound. The two molecules added up to form this product. On heating it, it readily loses a molecule of water. In this case, it is the OH group. OH group, from the carbon atom, OH group is lost. H lost from the next carbon atom. So in this case, there are two products are possible. If H lost from CH2, the product should be this CH double bond CH CHO, CH3CH double bond CH CHO. On the other hand, if H lost from the terminal alkyl group, the product should be this. It is 1, it's 2. If they ask you which of them is the major one, it is alpha beta unsaturated carbonyl compound. Both of them are conjugated and it is more stable. It is less stable. Hence, the beta hydroxy compound form, carbonyl compound form, loses a molecule of water. Elimination of water takes place in such a way, from the carbon atom OH group is lost, H lost from the next carbon atom of the OH group having less number of hydrogen. Look at here, CH2 contains 2 hydrogen, CH3 contains 3 hydrogen. So when H lost from CH2, we should get an alpha beta unsaturated carbonyl compound, and it is more stable. So major product will be 2-butanal, but2-in-1-al, and minor product would be 1,2,3, 3-butanal. 2-butanal is the major one because it is conjugated, two double bond are conjugated, it will be more stable. So on heat, on Aldol condensation reaction of carbonyl molecule, same carbonyl molecule, it form two products. One of them is major, one of them is minor. If I take two carbonyl molecule different, in this case 4 products are obtained. Now let us see another case. It is the case of Aldol condensation of your ethanol. If I take the Aldol condensation of propanol, what it would be? Propanol will be this. It is H. Take another molecule, same molecule I am taking. In this case, this carbon is the alpha carbon, dotted one, this carbon is the alpha carbon. When it is enolizes in presence of alkali, it forms this. It is the next molecule. The carbon ion attack the carbon atom of carbonyl group, who gives you this. H. This is carbon, this is CH3, this is CH2, this is CO minus H, this is CH, CH3, because it is the alpha carbon from which hydrogen is lost, not from the beta one. It is CH3. It is C double bond OH. It's from this. In this case, major product will be this one, OH from here, H from here, because it contains one hydrogen, it contains two hydrogen. So the major product should be this. This is the major. Minor product will be loss of hydrogen from this CH2 hydrogen, should be this. This is the minor. In this case, one thing I have done a bit mistake over here. I am showing it again in the next part. Yes, so this is the first one. This hydrogen analyzes in place of dilute alkali to form carbon ion. This attack the carbon of the carbonyl group, forming this. In place of dilute alkali, in place of water, it forms this. OHH, then it is CH, CH3, C double bond OH. Now OH lost from here, H from the next carbon atom. Next carbon, I will prefer this carbon because it contains one hydrogen, it contains two hydrogen. So the major product should be this. It is the alpha carbon, it is the beta carbon, alpha beta unsaturated carbon compound. If H lost from the alternates one, it will be product from this. Okay, it will be the alternate one. It will be the alternate one. It will be the major product. It will be the major product. CH3, CH, CH. In this case, H lost from the carbon next to OH group with one hydrogen. In this case, this hydrogen is lost to gives you this as the major product. In this case, H is lost from here and OH from here to form the double bond over here. And in other case, if you think of the other one, in this case, H will be lost from here to give the second product. So it is the first one, it is the second one. In this case, one is the major product, two is the minor one. Now, in these cases, I have taken two different carbon molecule, two same carbon molecule which undergo aldol condensation. It is an example of intermolecular aldol condensation reaction. Now I should consider a case when both the carbon molecule are the part of both the carbonyl group are the part of the same molecule. Look at here, I am showing an example to you. Think of this case. See, both the carbon group are the part of the same molecule. I am showing with a mechanism to you. It is CH3 group. For your understanding, it is CH2, it is CH2, it is C double bond OH with dilute alkali because it is electron attracting. So the carbon the hydrogen attached to the alpha carbon will be acidic enough to be analyzes to form carbon ion, forming this as an intermediate first. I am doing a bit slowly such that you can follow it everything clearly. Now the carbon and attack it over here. This is lost. To gives you this CH2, CH2, C, O minus H. It is a 1, 2, 3, 4, 5. 5-membered cyclic compound is formed. I can write it this way also. Look at here, it is C double bond O group. And next carbon is CH2. And after that carbon, in this case, it is O minus is there, H is there. So one CH2 is in between C double bond O and the carbon to which O minus and H is attached, and C double bond O attached with other two CH2 group. With dilute alkali, it forms this. OH and H. Now this is the beta hydroxy carbonyl compound. In this case OH is lost. H from the next carbon atom, H will be lost in such a way such that it forms alpha beta unsaturated carbonyl compound, because in this case both of them contain 2 hydrogen. So choice is same. This is the compound formed. It is an example of internal Aldol condensation reaction. It's called Now I'll show you another example of internal Aldol condensation. Look at this example. The drawing is not so clear. I am writing it again for you. C double bond O, C double bond O, okay. Now in this case it has a carbonyl compound, cyclic carbonyl compound, dicarbonyl compound having alpha hydrogen. So in case of dilute alkali, it enolizes to form carbon ion in the first stage. Suppose in case of dilute alkali, it form carbon ion. This carbon ion attack these molecules. You see, this is the carbon ion form. This carbon ion attack the molecule, and it will be lost. So it will be like that. I am showing it over here such that you can follow it much clearly. Suppose CH2, CH2, C double bond O, C double bond O, CH2, 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 CH2. Close it. Now in this case what happened? It form enolizes with dilute alkali. It enolizes to form carbon ion. So what it will be? CH2, CH2, C double bond O, C double bond O, CH2, 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 again CH minus. This CH minus will attack it and will be lost. So forming this O minus, then CH2, then CH2, then C double bond O, then CH. This is closed a cyclic structure is formed over here. Then CH2, CH2, CH2. Close it. So in this case 1, 2, 3, 4, 1, 2, 3, 4, 5 member ring is formed. In this case 1, 2, 3, 4, 1, 2, 3, 4, 5. In both the cases it forms a 5 member ring. After that what happened? There is OH minus is there, H2 is there, H2 forming what? CH2, 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 OH, then C double bond O, then CH, then CH2, then CH2, CH2, CH2. After that OH and H is lost to form a double bond over here. I think you haven't followed it so clearly. Again I am doing it for you. Another example. Think of the case of this. It will be too tough for you at this moment. Think of the case of these two carbonyl molecules. That part I will show you. Don't worry, I will show you. OH minus. It from carbon ion. CH minus. It attack the carbonyl group and the bond will be lost in this way. O minus, then C, then C double bond O, C double bond O, the structure will be like that. Another case, it is C. It will be O minus, C double bond O. Have you followed it? If you don't follow it, again I am showing it to you. Suppose it is cyclohexanone. Take next molecule. Don't worry, I will make it clear to you. It is alpha carbon. OH minus enolizes to form this. This negative charge attack the carbon and the bond will be lost this way. Third step. Next molecule with C double bond O, H2O, forming this. OH is lost from here. H, this is CH2, this is CH2, this is CH. So H will be lost from here to gives you this as the structure. As you see, C double bond O is there, OH is lost from here, H is lost from here, and double bond is formed over here. So this is the compound formed. This is basically aldol condensation reaction between two carbonyl molecules. Now I will show you the last case, aldol condensation reaction, internal aldol condensation reaction. Look at it. I am showing it to you. Suppose I have taken this compound. Then then I have taken another CH2, then this is another CH2, this is a CH2. Okay, this is the case. Now in this case, it forms carbon ion with dilute alkali. It forms carbon ion, so structure will be this. CH minus, CH2, 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 CH2. This will attack over here, it will be lost, so gives you this CH2, CH2, C, O minus, then C double bond O, then we have CH which attack it over here. Now we have CH2, 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 this bond. It become 1, 2, 3, 4, 1, 2, 3, 4, 5 membered ring. In this case 1, 2, 3, 1, 2, 3, 4, 5 membered ring. Then H2 gives you COH, CH2, CH2, C double bonded O, then we have CH, CH, then we have CH2, 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 this on heating will lose a molecule of water. H will be lost from here to gives you CH2, CH2, C, in this case C double bond O, in this case this C will be double bonded, then we have CH2, CH2, in this case we have CH2, CH2, this CH2 will be bonded over here. I hope you may find it a bit difficult, but the other portion which I have explained is hopefully it will be clear to you. If any doubt, you can write on my WhatsApp number. Thank you for today's class.